In this video, we're going to go over the last three properties of your logs. And so we have sum of logs, difference of logs, and power. So your sum of logs says if you have log base b of m times n, you can expand this out and say log base b of m plus log base b of n. And this works the opposite way as well. So I can go from here to this one here. And so in this example, because this one's already expanded out, I am going to be bringing it over here and condensing it, while this one here is already condensed. So then I'm going to expand it out. Typically, it's going to tell you in the instructions, if you look at the next page, it says write the expression as a sum and or difference. So that means expand it out. Or it will tell you write the expression as a single log, so you need to condense it. Okay, so it will typically tell you which, if you're going from here to here, or here to here, but with these, we're just kind of doing the opposite of what we have. So for example, we have log base 12 of 2 plus log base 12 of 6. Because they are both log base of 12, I can write it as a single log base of 12. So I got log base 12 of 2 times 6, which is log base 12 of 12. And from that first video, if your base is the same as what that big number is, then they cancel each other out, which is the case here. So those cancel. And so my final answer is just simply 1. Okay, on B, you have the same base again because they're both natural logs with the base of E. So we've got natural log of 5x times x plus 1. Now, while this is technically in my form, I can simplify this a little bit. I would say MyMathLab would take this answer, but we can go one step further. So let's go one step further by distributing that 5x. So this is the natural log of 5x squared plus 5x. Okay, and notice that all of that is in parentheses. If you just give me the natural log of 5x squared plus 5x with no parentheses, and you're telling me we're just taking the natural log of 5x squared. So you need all of that in parentheses. Okay, and with this one, now we're going to go the opposite way. So now this is my product. And we're going to expand. Oh, excuse me. Okay, so we have a common log with a base of 10. So this is log of 1,000 plus log of x. This one here, I can rewrite 1,000 with a base of 10. That would be the same as log of base 10 is just known to be there, right? And that's a common log of known base 10. So log of 10 cubed. And I'm just going to rewrite my log of x. And so this is another property that we went over. When you have log base b of b to the x, these cancel and you're left with what the exponent is. So this cancels. So my final answer is 3 plus log of x. Okay, so that's your sum of logs. Let's go to difference of logs. Difference of logs says if I have log base b of m over n, that equals log base b of m minus log base b of n. So you can tell when these are being divided because you're subtracting your logs versus adding your logs. So again, if it's already expanded, we're condensing. If it's already condensed, then we're expanding. So here, log base 5 of 40 minus log base 5 of 10, because they both have log base 5, I can condense to log base 5 of, and because this is now being subtracted, I know I am dividing these numbers. So 40 divided by 10. So this is log base 5 of 4. Okay, so now this is condensed. So now I'm going to expand. So because these are divided, I know I'm subtracting. So this is log of 100 minus log of x. And I can simplify log of 100. This is a common log with a known base of 10. So I can write 100 as a base of 10 by doing log of 10 squared minus log of x. We've got base 10 and 10, so those cancel. And so my final answer is 2 minus log x. Okay, and then lastly here, we have the natural log, and I'm dividing, so I know I'm subtracting. So natural log of x plus 2, so that needs to go in parentheses, minus, because we're dividing, natural log of e to the 8x. This is the same as what's been happening here. This has a known base of e, so those are going to cancel, and this is going to simplify to just what the exponent is. So my final answer is natural log of x plus 2 minus 8x. Okay, and then the last property we're going to go over is our powers. So this again works both ways, but if I have log base b of m to the r power, I can take this exponent and I can move it out front where it is now r times log base b of m. Or if it's like this, I can take whatever is, I can take whatever is being multiplied in front of that r and move it back up here to become the exponent of m to the r power. So it says, well, so here, if it's got an exponent, we're moving it in front. If it's got something in front, we're moving it up to an exponent. And it tells you in instructions to express powers as factors, meaning move it in front so it's being multiplied. So this one, we're simply moving that x right here in front. So this is x log base 7 of 8. Okay, now I'm going opposite and I'm moving my factor to an exponent. So this is log x squared. And then lastly, we'll move this x in front for x natural log 4. Now this rule is really helpful for us because I told you we're going to keep going back and forth to this property here. Okay, so let's go back to number 5 because this is where we needed this to be able to solve this. Okay, so back to number 5. We've already used this property in this manner here. If you have log base b of m equals log base b of n, you cancel those out and just equals m and n. That's what we did. We had natural log and we canceled both of those out. So now with this one, I need to go in the opposite direction. So I have this side y to the 4th. Let's change that. I have this side 4 to the y power equals 17. So this is my m, this is my n. So what this tells me I can do is I can add a log with the same base to both sides. So I can do any log base of anything. And in the future, we're going to pick those bases strategically. But for this lesson here, I'm going to do just a common log. So I've got log of 4 to the y power equals log of 17. So I just added, that was my equation. I just added the common log to both sides, which has a base of 10, right? And I'm adding this because on my calculator here, I have the common log on my calculator. So I could have also done natural log, and I could have done natural log of 4 to the y power equals natural log of 17. Okay. Now this property comes into effect because I have no way of solving for a variable when it is in the exponent position. But what I can do is I can move this exponent and move it over here in front and turn that into a factor. So now I've got y log 4 equals log 17. And now I can solve for y. This is just y times log of 4. So I can divide my log 4 over on both sides. And so now I can put this into my calculator, and I shouldn't have canceled that. This is what was supposed to cancel. So let me. Okay. My log base 4 or my log 4 over log 4 cancel. And so now I can put this into my calculator. So we got log 17, closure parentheses, divided by log of 4. And we get about, let's go 2.0437. This is where we're going next lesson. So this is really more for next lesson. If you do any homework over this, it's going to be more in this form here. But I wanted to explain what this is actually talking about. And so this is what we're going to be doing next lesson, is actually solving these. So I'm going to stop the video here. We're going to learn a second way to do this exact same problem using another property from this lesson.